Friends, subscribe my channel Netbook of Physics and press bell icon for latest update.
In this lesson, we are going to learn about Stokes' law and terminal velocity. If a spherical object of radius r is moving through a column of viscous liquid, then the viscous force on this body is given by Stokes' law. Stokes' law tells us that this viscous force is 6 pi eta RV. So this is the formula for viscous force. Viscous force is 6 pi eta RV. Eta is coefficient of viscosity, r is radius of the spherical object, and v is the velocity of the spherical object. So this is the formula for viscous force. Based on this, we get the concept of terminal velocity. So what is this terminal velocity? So spherical object is falling through a large column of viscous fluid, right? So this body starts falling. Initial velocity says 0. So what are the forces acting on this? The weight is acting vertically downwards, and there is a buoyant force acting upwards. So only these two forces will act on the body when the velocity is 0, right? As the body starts moving down, if mg is greater than b, weight is more than the buoyant force, this body will accelerate downwards. As it accelerates downward, it picks up velocity. As it picks velocity, the viscous force increases because viscous force depends on velocity. So now weight is acting vertically downwards, the buoyant force is acting upwards, and the viscous force, we can call that capital V, that also is acting upwards. So weight is acting down, buoyant force is acting up, these two are fixed forces. The viscous force depends on velocity. And as this body is going down, the velocity is increasing. As velocity increases, viscous force increases. Now at some point of time, it may happen that the weight is equal to B plus V. Right here, weight was more than B, so this body started accelerating downwards. Now here, as the viscous force increases, at some point of time, if weight becomes equal to V plus V, net force becomes 0, velocity becomes constant. Now that body will come down with constant velocity, and that we call terminal velocity. So weight is volume, 4 by 3 pi r cube. That is the volume into density of the solid, whatever solid is flowing through that viscous fluid, and multiplied by g, this is mass. Volume into density is mass, mass into g gives us weight. So this is the weight. The buoyant force is weight of the liquid displaced, that will be 4 by 3 pi r cube, that is the volume. Again, density of liquid into g, so that is the weight of liquid displaced. And the viscous force is given by 6 pi eta RV. And when all these are balanced, we get terminal velocities, we can call it Vt. So from this, we get the formula for terminal velocity, Vt equal to, this will come this side, so we'll get a minus sign there, then this will become 26, will come this side, so it is 4 by 18, that is 2 by 9. So we get 2 by 9. Then we get this eta, so this eta will come. Then this r here you got r cube, so you'll get r square. So r square. Then rho of solid minus rho of liquid. rho of solid minus rho of liquid. Right? What else we get as terminal velocity? Pi cancels from everywhere. So pi is gone. So 2 by 9 r square rho s minus rho l, and this g also will be there. So rho s minus rho l into g. So this is the formula for terminal velocity, 2r square rho s minus rho l g by 9 eta. If you make a graph of velocity with time, initially velocity will increase till it reaches terminal velocity, that is the final velocity. And because of this terminal velocity, cats are able to jump from tall buildings, because after some time the velocity does not increase. It reaches terminal velocity. They spread their body and they reach a terminal velocity and they are able to fall safely from large buildings. Right? Jump safely from tall buildings. Same way, in a parachute, that person coming down the parachute reaches terminal velocity, that's why they are able to come to the ground. So this is the concept of terminal velocity. Terminal velocity is 2 by 9 eta r square g rho s minus rho l. So this is the concept of terminal velocity. Stokes law tells us viscous force equal to 6 pi eta r phi. Terminal velocity, when a body is falling, when a solid body is falling through a large column of viscous liquid, as the speed of the body increases, viscous force increases. If weight becomes equal to viscous force plus buoyant force, the net force will become 0. The body will reach a terminal velocity. For a spherical object falling through a large column of viscous fluid, the terminal velocity is 2r square g by 9 eta rho s minus rho l.